Hello everyone, welcome to my channel and today we are going to start our new series of questions of interviews which are very important if you are giving a DSA round in any of a company. Like it is not mandatory that it should be a farm company or any MNC based company only. Nowadays, all the companies uh, tend to ask these questions and all the companies ask these questions to test some basic skills of the students and the professionals that they are able to solve the problems because ultimately it's all about the problem solving and that they want to test this skill by doing or taking this DSA tests. So you have to be prepared for that. Uh, and the best way to prepare is by doing practice. And we are going to do that. So this is the playlist and the list given by LeetCode which contains 150 questions. And I assure you that this is the very well curated list and it is a very well made list which covers almost all topics which you need to be preparing. So let us start with the questions. And our first question is merge sorted array. Let us see what it tells. So what here it is given that we have two arrays which are non-decreasing order and we have to merge them in a way that the resulting array will be sorted in non-decreasing order. Now, one catch is that we don't have to use another array or any other space. So what we have to do is that we have to put the second array elements into the first one. The first one is a given large array, and all the other elements which needed to be inserted are marked as 0. So let us move towards the here so that we can properly understand that. So what we have given is that we have array 1. This is the array 1. This is the array 2. And we have to get this. This is our output. Okay. And so let us see how we can do that. So first thing will be to the sort, just sort it. Like we can place those elements here, 2, 5, 6, and just sort it. But the problem is that the time complexity of that solution will be O of n, which will be inserting complexity. Now, what will be the sorting? We will also need the n log n. This is the general sorting complexity that we get. Now, if we want to be specific, then what will be this will be the m plus n, and this will be also m plus n. So effectively, it will be around O of n log n. So it will be order of 1 log n, but we have to do it in O of n time complexity. So how we can do that? Let us see how we can do that. Now, what we are going to do is that we are going to insert this element here from last. And why I'm saying last is that let us try to insert from start. So if we will insert this 2 here, then what will happen is that we have to arrange this 1 somewhere else. And that will be also causing some complexity. And same for 5 and 6. So we don't have any empty space here. So the intuitive way will be to place the elements there where there are no elements present. So what we will going to do is that we will be having two pointers. First one will be I. This will be I pointer. Second one will be J pointer. So this is not the. So J will be pointing towards this and I will be pointing to this. Okay. Let us move it from here so that it won't create any problem. Okay. So we know that I is pointing to 3 and J is pointing to 6. Now what will happen is that we will be comparing those 3 and 6. So let us compare, and the bigger element is 6. So what we will do is that we will place the 6 here. So this will be the 6. Now what we will do is that move k to one place here, and whose element was greater? It was second array. This is array second. This is array first. So the second array element was greater. So what we will do is that decrease the pointer j, and yeah, decrease the pointer j. Now what we will do is we will again compare I and j. Now 3 and 5, again the 5 is greater and array 2. So what we will do is that we will change this to 5. Now again we have to decrease the j pointer. Now, yeah, this is the case. What will happen is that we will compare 3 and 2 again. In this case, the array one element is greater, which is 3. So we will point 3, we'll keep 3 as it is. What we will do is that 3 will be kept on k's position. I forgot to move the k pointer. So we will move 3 here. So this is this. Now what we will do is that decrease the I pointer because the array one element was greater. So we will decrease the I pointer. And now let us see what we will do. 2 and 2. So we can take any one of them. So let us take 2. And what we will do is that we have all decreased the k pointer. And yeah, so k pointer will be here. What we will do is that we will mark it as 2. Decrease the I pointer because the array one element was greater. It was same here. Okay. J is same. Now k will be pointing to here. K will be pointing to here. Now, what we will do is that we will compare it. So the j element is greater. So what we will do is that we will mark it as 2. It's already 2, but this was not the 2 from array 1 elements. This is the 2 from array 2 elements. So make it remember. So now what will happen is that we have exhausted the array 2. So array 2 is exhausted. So uh, array 1 elements are remaining. So that will be in their place only. So that is the thing. We don't have to repeat for all the elements again because they are already in their place. Like one is already in their place, and we were also given that the both arrays were non-decreasing order, means all were sorted arrays before. So we don't have to do anything in this case. And yeah, but if the elements of this array was remaining, what we would have done is that we would have inserted those elements directly into that place without comparing. We will see it in an example where we code. And so that was the core logic behind that. We have to use the first array itself. We have to use no extra space. That was the questions. And now if we see what we have time complexity here. So the time complexity will be of order of n. Why? Because we are traversing the list only one time. If you see that we are moving from k here all the way to 0. So this can go up to worst case O of n, which is still better than the previous solution. So the new complexity would be O of n order. Space complexity, this is time complexity. Now here what will be space complexity? It will be O of 1 because we don't need anything. We have just used two pointers which are constant space. So the time complexity and space complexity will be this. So let us code, and if you are having any doubt, that will be cleared there. Okay, so let us solve this problem. As we have discussed that we will be using two pointers, and I will be pointed to the last valid element of first array. J will be pointing to the last valid element of second array, and K will be pointing to the last element of first array. The empty elements. We will be traversing both arrays J to 0. We will check condition if nums 1 of I is greater than nums 2 of J. So if first array element is greater, then we will insert that element at position K. So nums 1 of I. We have to decrease both the pointers. In another case, if the second array element is greater, what we have to do is that we have to insert, make sure that you are inserting in nums1 only, because we have to insert and return the same array. So we will decrease the pointer k minus minus. So this will be the thing. Now what will happen is that one of the array will get exhausted, and if second array is shorter, like in this case second array is shorter, what will happen is that we have to insert those elements directly into the array 1 without comparing. So let us check. So if array 1 elements are exhausted, and the remaining elements of array 2 will be inserted. So what we will do is that nums 1 of k will be nums 2 of j. We will also decrease the pointers. Now we have already discussed that we don't need this thing for I, as we are only inserting in first array itself. So if the second array is exhausted, then the elements are already there. So we don't need this thing for the for the first array. Let us arrange this thing. Now we will run this code, and it is accepted. Let us submit this. Okay, let us analyze this complexity. Complexity given is O of m plus n. Let us see how it is O of m plus n. So what we are doing here is that we are traversing effectively only first array, because we are traversing from k is equals to m plus n minus 1 to k is equals to 0. So what we are doing is that we are effectively traversing first array. So the time complexity will be equal to the size of the first array. And what is the size of first array? It is given O means m plus n. So time complexity will be O of m plus n. Okay. What will be the space complexity? Space complexity will be constant space, because we have not used any extra space for the solution. We have already mentioned that we can't use any other extra space, so that's the solution, and that is the optimized solution we can get. So the thing is that we have to always start from the brute force approach. The brute force approach in this question was to try to sort the array, but the time complexity was O of n log n. Now what we will do is that we will optimize that. So that's what approach you have to follow in interviews as well. Like first try to solve it with brute force. Don't directly jump on the solution, optimized solution. It will create a negative effect. And if you are not able to solve the optimized approach, then you can't go back to the brute force. But you can always go back to the optimized solution. So keep this thing in mind while giving interviews. We will solve next questions, and I will upload the next videos. We will solve all the questions to it. Okay, thank you. We'll meet in next video. Thank you so much.